In this example, we're being asked to find a definite integral. You'll know it's a definite integral because your integral symbol will have bounds. So we've got numbers here, a lower bound of 3 and an upper bound of 7. So this is saying find the antiderivative, the integral from 3 to 7 of 6x plus 9 dx. The integral symbol up in the front and the dx at the back are really just directions telling us what to do to this equation in the middle. So we're going to look to find the antiderivative of that. Really, the good news about antiderivatives is we don't have a lot of rules, and we've got a main rule that we'll use here, which is the power rule. We had a power rule for derivatives. We have a power rule for antiderivatives. The power rule for antiderivatives works the opposite. We're going to add 1 to the power, and then after you do that, you're going to divide by the new power. So we come over to our antiderivative. There's an unwritten 1 on that x. We add 1 to the power. That's going to get us 6x squared. And then you're going to divide by that new power. So divide by 2. Plus, and then the antiderivative of 9. When we were taking derivatives, constants, numbers by themselves, went away. When we're undoing derivatives, we're going back the other direction, so constants are going to gain a letter back. So that's our antiderivative. And when we've got bounds on it, we add this little piece at the end. We say evaluated from x equals 3 to x equals 7. And the method you want to use here as you're working with integrals is really top minus bottom. We need to get out a definite answer, a definite number. So we're going to take the top value, plug it into this equation, and then we are going to subtract off the bottom value plugged into that same equation. So coming through here, we really can kind of clean this thing up. The 6 and the 2 would cancel, leaving us with 3x squared. So as much simplification as you can do, it's helpful. So we get 3, and then instead of x, we plug in our top value, which is 7 squared plus 9. And then again, plugging in for x, our top value, we plug in 7. So there's the top. And then off of that, we are going to subtract the bottom value plugged in. So plugging in 3 to that equation, we get 3 in place of x squared plus 9 times 3. Now all you need to do is just go through and evaluate those two answers. So then this front piece ends up giving us a total of 210 when we plug that in. Subtract off, this back piece ends up giving us a total of 54. Subtracting those two from each other, and we end up with 156 for our final answer for this definite integral. So the area between the curve and the x-axis between 3 and 7, the net result is 156. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.